Hello everyone, welcome to my class. In today's class, I'll cover power series. So let me start the class right away. First, quick overview. So far in preceding sections, we studied three types of series: the positive term series, alternating term series, and plus and minus term series. So now we study another type of series whose terms are a function of x, that is a power of x. So instead of the sum of the series is a number, now it deals with the sum of a series is a function. Quick example, for x in minus 1, 1, the sum of the series xn equals to, it turns out to be 1 over 1 minus x, now which defines the functions of x. Let me define a power series. Power series is a series in x minus a of the form summation n cn times x minus a to the power n. In the expanded form, so c0 plus c1 x minus a plus c2 x minus a square plus ... where cn's are constant known as coefficients of the power series, and x equals to a is the center of the power series. So if center of the power series is origin, then our power series is of the form summation n of cn times x to the power n. Note, it's a convention to assume that x minus a to the power 0 is 1 even when x equals to a. Quick questions to ask ourselves: when and where does the power series converge? That is, where it defines a function of x. Idea: there are three possibilities. The power series converges when x equals to a. I think this is the trivial case. Put x equals to a, then this gives me simply the c0, which is constant function. The power series converges for all x, or there is a number r such that the power series converges absolutely when our absolute value of x minus a less than r, and diverges when absolute value of x minus a is greater than r. So in visualizations, let's see in this diagram, a is the center of power series. There is a number r which is called a radius of convergence, this distance, and then the intervals, here is a minus r, a plus r. So inside this interval, the series converges absolutely. Outside this intervals diverges, and at the end point of this intervals, which is a minus r and a plus r, we don't know whether they converge or diverge. So the number r is called the radius of convergence, and the intervals a minus r to a plus r is called interval of convergence. The power series converges absolutely in the interior of I, and it's tricky to determine whether it's converged or diverged at the end points at x equals to a plus minus r. The primary tools to determine whether the power series converge or diverge is by the ratio test. Sometimes we use root test also. A quick recall of the ratio test. The ratio test says limit n goes to infinite of absolute value of the ratio of n plus 1 term over n term. If this is less than 1, the series absolutely converges. If this is strictly greater than 1, the series diverges. If the series is exactly equal to 1, the test is inconclusive. By the way, if the limit of this absolute value of the ratio of n plus 1 term or n term equals to infinite, then radius of convergence is 0. And if limit n tends to infinite of the absolute value of the ratio of n plus 1 term over n term is 0, then radius of convergence turns out to be infinite. The interval of convergence I can be of three types: an infinite interval, means whole real lines, or a collapsed intervals, which is a singleton set is 0, or a finite intervals, means a minus r, a plus r, open intervals, or left open intervals or right open intervals or closed intervals. Quick example, the power series summation xn equals to 1 plus x square plus dot dot dot, which equals to 1 over 1 minus x, has a center at origin. Radius convergence is 1 and interval convergence is open intervals minus 1 1. Great. Now let's move on. Two conceptual questions let's ask here and answer as well. Questions 1. If the power series summation cn 5 to the n is convergent, then what can we say about the series summations cn times negative 3 power n? This is a quick solution. We are given the power series summation cn xn is convergent for x equals to 5. So it must converge for at least x between negative 5 and 5. So in particular, it converges for x equals to negative 3. So the series summations cn times minus 3 to the power n is convergent. Question number 2. Suppose that the radius of convergence of the power series summation cn xn is r, then what is the radius of convergence of the power series summation cn times x to the power 5n? Solution. Note the power series summation cn xn converges whenever absolute value of x is less than r. So the given series summation n cn x to the power 5n, which is same as summations n cn times xn outside power 5, converges whenever x to the power 5 is less than r. That means the x is less than fifth root of r. So the radius of convergence of this given series cn x to the power 5n is fifth root of r. Great. So now let's solve some example. Worked example. Find the radius of convergence and the interval convergence of the power series. Questions part A. Given power series is summation n of x minus 2 to the power n over n square plus 1. So here an equals to x minus 2 outside power n over n square plus 1, and we know the power series converges for at least x equals to 2, which is the center. So now let's use ratio test. So the limit n goes to infinite of the absolute value of the ratio of n plus 1th term over nth term equals to limit as it is, then n plus 1th term, here replace n equals to n plus 1, so then x minus 2 power n plus 1 over n plus 1 outside is square plus 1, that's n plus 1th term, and then divide by nth term means x minus 2 outside power n over n square plus 1, then we flip it here. Then let's cancel here. We can cancel this x minus 2 power n and x minus 2 power n cancel, so we only have x minus 2 power 1 left, so we can pull outside the limit, and limit n goes to infinite, the second term as it is, n square plus 1 over n plus 1 outside is square plus 1. You FOIL this one, it gives us n square plus 2n plus 2. Then the limit of this fractions n square plus 1 over n square plus 2n plus 2 turns out to be 1. So we have this limit of this ratio equals to x minus 2. Consequently, the power series converges for this number x minus 2 less than 1. That means the radius of convergence is 1. Simplify for x, so x lies between 1 and 3. So we have the interval convergence 1, 3, but at the end point at 1 or at 3, we have to check separately. So let's check at the endpoints. So at x equals to the left endpoint 1, the power series reduces to, this is the given power series. Let's put x equals to 1. So this gives me the series of negative 1 to the power n over n square plus 1. And this converges by alternating series test. Next, let's talk about right endpoint at x equals to 3. This is the given series, summation x minus 2 power n over n square plus 1 equals to, put x equals to 3, so 3 minus 2 is 1. So 1 power n over n square plus 1, which is same as summations 1 over n square plus 1. It converges by the comparison test, since 1 over n square plus 1 is less or equals to 1 over n square. And then this bigger series converges being a p series where p equals to 2 greater than 1. Then by the comparison test, the smaller series converges. Hence, our power series converges at both endpoints. So our interval convergence is closed interval 1, 3. Great. I hope this makes sense to you all. Let's move on. Questions part B. The given power series is x to the power n over n factorial. So let's begin the solutions. Use the ratio test again. So here an equals to x to the power n over n factorial. Then use ratio test. Limit n goes to infinite of the absolute value of the ratio of n plus 1 term over nth term equals to limit as it is. Here is x n plus 1th term, so x power n plus 1 over n plus 1 factorial, and divide by xn over n factorial, means you flip it. We know dividing is same as multiplying by its reciprocal. Then here x to the n cancel, so 1x out, right? And then the factorial, this n plus 1 factorial, we can rewrite as n plus 1 times n factorial, then cancel the n factorial. So we only have limit n 1 over n plus 1. The limit of this fraction, when n goes to infinite, this n goes to infinite, means this fraction goes to 0. That means for any x, our limit of this ratio is 0. That means our radius of convergence is infinite, and interval convergence is whole real line. Great. Let's move on. Questions part C. Given power series is n to the power n times x to the power n. Summation n runs from 1 to infinite. Just routine computations. Let's begin the solution. Use root test here. Begin the solutions. Here n equals to n to the power n times x to the power n. So our terms involves the power n. So let's use the root test. So the root test says limit of n goes to infinite of nth root of absolute value of an equals to limit n goes to infinite. Then the nth root and nth power cancel. So we only have nx. We can pull the absolute x outside. So limit of n only. And I don't need that value for n is a positive number here. So when n goes to infinite, n goes to infinite. That means for any value of x, this nth root of an is infinite, which means that means divergent. So our radius of convergence is 0, and interval convergence is singleton set 0. That means the power series converges only at origin. Great. Let's move on. Questions D. Questions part D. Given power series is summations n runs from 1 to infinite of xn over n times 4 to the power n. Begin the solutions. Here's an equals to xn over n times 4n. So now, let's use ratio test. So for any non-zero x, limit of the absolute value of the n plus 1 term over nth term equals to limit. The n plus 1 term is x to the power n plus 1 over n plus 1 times 4 power n plus 1 and then divide by nth term means flip it, so n times 4n over x to the power n. Great. Then let's simplify. We can here 4 to the power n, 1 4 to the power n cancels, 1 x to the n, 1 x to the n cancels, so we have absolute x out, from here 4 out, and then limit of n over n plus 1 left. The limit of this fraction goes to 1, that means we only have absolute x over 4. Then consequently, our power series converges when this absolute x over 4 less than 1. This implies absolute x is less than multiplied by 4, which is 4. So our radius of convergence is 4. And interval convergence is minus 4 comma 4. But let's check at the end point separately. So at the end point, at x equals to left hand point, the series, this is the given series xn over n times 4n, put x equals to minus 4, so minus 1 to the power n times 4 to the power n over n times 4 to the power n, which is same as summations of negative 1 power n over n. And we know this is an alternating harmonic series, this converges. That means we now include our interval convergence, include the left hand point. How about the right hand point? Similarly, at x equals to right hand point 4, the series, this is the given series, equals to, put x equals to 4, then 4 to the n, 4 to the n cancel, so only have the series of 1 over n, and we know this is a harmonic series, it diverges. So then our interval convergence is including negative 4, excluding positive 4. So minus 4 to 4, excluding positive 4. Great. Now let's do another example. Questions part E. The given power series is summation of negative 1 power n minus 1 times x to the power n over n. Let me foil this one. It looks like in expanded form x minus x squared over 2 plus x cubed over 3 minus x 4 over 4 plus dot dot dot. So here an equals to xn over n. Xn over n. Let's use the ratio test. So the ratio test says limit n goes to infinite of absolute value of the ratio of n plus 1th term over nth term equals to, so n plus 1 is, replace n by n plus 1, so x to the power n plus 1 over n plus 1, and then divide by xn over n, means flip it, n over x to the power n. Again simplify. So here x to the n cancel to x to the n cancel, so only x left, so pull absolute x outside, limit as it is, n over n plus 1 here. And we know the limit of n over n plus 1 goes to 1, so we only have absolute x. Consequently, the power series converges when this absolute x is less than 1, so our radius of convergence is 1. And the interval convergence is x between negative 1, 1, that means negative 1 comma positive 1 at least. Now let's check at the end point. At the end point, at the left hand point, at x equals to negative 1, the series reduced to this series here, put x equals to minus 1, this reduced to negative outside, 1 plus 1 half plus 1 third plus dot dot dot. This diverges, this is a harmonic series, so we have to exclude the left hand point. How about the right hand point? At x equals to 1, the series reduced to 1 minus 1 half plus 1 third minus 1 fourth. This is an alternating harmonic series, it converges. Therefore, our interval convergence is negative 1, 1, excluding left hand point, including right hand point. Great. So we finished these sections. Thank you.